Bismillahir Rahmanir Rahim. Welcome to MIT. Today we are going to solve a question from Mechanics 43. The paper is 9709/43 for the session October November 2024. That means the latest paper of Mechanics 43. So let's see the question. We are going to solve question number 7. Question number 7 is, let me mark over here. This is question number 7. Two particles A and B of masses 3 kg and 5 kg respectively are connected by a light inextensible string that passes over a fixed smooth pulley. So pulley is smooth. The particles are held with the string taut and its straight parts vertical. Particle A is 1 meter above a horizontal plane and particle B is 2 meter above the plane. See the diagram. From the diagram we can see this is the plane, and above the plane particle A is lying 1 meter above, whereas particle B is lying 2 meter above. The particles are released from rest. In the subsequent motion, A does not reach the pulley, and after B reaches the plane, it remains in contact with the plane. That means whenever B comes down on the plane, then there is no more force active. The question number A say that find the tension in the string and time taken for B to reach the plane. Well, you can notice that I have already solved it. Now I am going to explain the point which should be clarified. Since the question requires two missing values, one is string, the other one is string as well as time taken. As there are two values missing, we will have to solve simultaneous equations. Before that, we'll have to form the equations. So for particle A and particle B individually, we will form the equations. And the concept, I think all of you know the concept which is going to be applied here, as this is all about the forces and time. So definitely it's concept of the motion law of Newton. So for B, individually we are talking about B. So let's talk about B. For B, B is coming down, isn't it? If I can show you, then look at this, B is coming down. Well, so the concept we are going to apply is the motion concept or the motion law of Newton. For B, driving force minus resistance force is equal to ma. Well, so our concept is driving force minus resistance force is equal to mass into acceleration. And for B, look at this, what is driving it downward? Actually there is no force, external force acting on this. B is just coming down. Look at this, B is just coming down when it is released from rest, and there is no other external force which is acting on B. That's why only driving force which may pull it downward is the weight of B. Weight of B is actually pulling it downward. So weight is the only force which is driving it downward. So we have written weight is the driving force, and resistance force is, and what is it resisting? Look, the part which is resisting particle B is the tension in the string. It is causing resistance. So only resistance force is the tension. There is no more force acting on this. So driving force is only weight, and resistance force is nothing but the tension in between them. So weight of the particle B is m, means 5. Weight is 5 kilo, and G, acceleration due to gravity is 10, and then tension unchanged, and mass is 5a. Okay, a is acceleration. So if we simplify, a can be transposed to the other side, then 5 tens are 50 minus t over 5. We can leave this as equation 1 because already I have told, as there are two missing values, So we will have to form two equations and we will have to solve them simultaneously. So for B, we got that A is equal to 50 minus T over 5 is the equation. Let's see the state of A. What is happening to A? A is, look at this, A is over here and it is moving upward by the tension. So only driving force acting on A is the tension. Tension is moving it upward. And what is the force resisting it downward is nothing but the weight. So it's just vice versa. In case of B, weight was driving it downward and tension was moving it backward. Whereas for A, weight is resisting towards downward and tension is moving it upward. So for A, tension is going upward, so tension is positive and driving force, and weight will be resisting force. So we will write for B, it is written, sorry, for A, driving force minus resistance force, the same concept of motion law of Newton. Driving force minus resistance force is equal to mass into acceleration. And I have already shown that driving force is nothing but the tension is moving it upward, so this is the driving force, whereas the weight is causing resistance. Weight is moving it downward, that's why weight is nothing but the resistance force. So driving force is tension minus resistance force, which is only weight, nothing else, because there is no other external force acting on the system. And right side is mass into acceleration. Well, so tension minus mass of particle BA, look, mass of particle A is given here, this is actually 3 kg. Okay, so we are going to apply this 3 t minus 3 into acceleration due to gravity is 10. So t minus 30 is equal to 3a. 3 is the mass of the particle. Then hence we can form the equation A is equal to t minus 30 over 3. So these are the two equations, equation 1 and 2. Look. Then solving this equation simultaneously, we get both of the left sides are A, so right side must be equal. 50 minus t over 5 is equal to t minus 30 over 3. So we are going to solve it. The equations are from equation 1 and 2. 50 minus t over 5 is equal to t minus 30 over 3. Then by doing cross multiplication, if we do cross multiplication, it is going to be 5t minus 150 and 350 is 150 minus 3t. So 5t minus 3t means 5t, 3t. If 3t is transposed to the left side, it is going to be 8t. 8t is equal to 150 plus 150 means 300. So ultimately we have got that our tension is 37.5 Newton if we divide 300 by 8. So we have got one of the answers. Then acceleration. For acceleration, you know, our acceleration was the equation in both cases. So this is our acceleration. Look, this this is our acceleration. Acceleration is equal to t minus 30 over 3. We'll just substitute the value of t. So it was 30 minus, look, that's not 30, it's a t minus 30, sorry. So t minus 30, we can I can show you from here also. The same equation is given here also. So t minus 30 over 3, and we have already obtained t is 37.5 minus 30 over 3. So if we do the simplification, 37 minus 30 means 7.5. If 7.5 is divided by 3, it will be actually 2.5. So our acceleration is 2.5. Though they didn't tell us to find acceleration, actually acceleration is required for the second part of the question. If we see the second part of the question, second part says the time taken for B to reach the plane. This is the plane, okay, and B is coming downward. B is coming downward, and they told that to find the time. So what is the concept we can apply? We know acceleration, we know we are supposed to find time, and we know the distance, I mean s, so we can apply the formula of Schubert formula, Schubert concept. So Schubert concept is for time and displacement is given. So for Schubert concept, we are going to apply S is equal to ut plus half at square. This is the suitable concept because we are searching for t and we do have S as well as acceleration, and we know u also. U was the initial velocity which was 0 because the particles were released from rest, so initial velocity was 0. That's why we are opting for this concept. You know the Schubert formula, S is equal to ut plus half at square. Those there are some variations, we just decide and find whether we do have all required values or not. Well, so S is 2 meters because let us see the graph. B will come down. B is at this stage. Okay, from this stage it will reach the plane, and distance between these two is given as 2 meter. So S is our 2 meter. 2 meter is our S. After that, so 2 equal to initial velocity because the particles were released from rest, it is 0. After that, half a acceleration is 2.5. Just we have found over here. Acceleration is 2.5 into t square. So it is going to be 2 on the left side, right side. Half of 2.5 is 1.25 t square. So if we transpose t on the left side, t is equal to square, for due to this square it is going to be square root of 2 over 1.25. That means t is equal to 1.26 seconds. This is the time which has been taken by B to reach the plane. I think the concept is very clear and very understandable. That simply what have we done? Let me go back to the question. The question was, let me zoom it in. Well, so the question told us to find the tension. First part is tension and second part is the time taken by B to reach the plane, the horizontal plane. Well, then for B, what is the concept? First concept here, as there are two simultaneous values are missing, then we will have to form two simultaneous equations and they will have to be solved for one by one individual. And the concept we have chosen is actually motion concept of Newton's law. So Newton law is we know for B, B is coming down. That's why the driving force minus resistance force, and same goes for the particle A also. For particle A, we applied the same concept. Okay, because this is nothing but the force and motions. Okay. After that, we have obtained A as well as T, tension as well as acceleration. The same tension and acceleration has been applied in the second part, solution of the second parts. Whenever we obtain tension as well as acceleration, look, this is acceleration. This acceleration it has been reused in for the solution of the part B, that is time taken to for B to reach the plane. So we know S, that means displacement or distance, because the distance is given here. It's given 2 meter. From the figure we can see it is 2 meters actually. So we know S, and initial velocity was 0. We know the initial velocity, and acceleration has also been obtained. So we can easily apply the Schubert formula, S equal to ut plus half at square. Then finally we got that B will take 1.26 second to reach the plane. I think you have understood as per my description or explanation. Let's see what the question B says. Question B says, find the time for which A is at least 3.25 meter above the plane. So the question seems to be very simple, but there is a twist in this question because the time, which time has been mentioned. I'm going to clarify it stepwise. First of all, we should know that the total distance is 3.25. Well, so how can we calculate 2.35? Let's see the figure again. The figure is, this is our figure. Well, in this figure, look at this. They told the distance should be at least 3.25. So at least 3 point we can calculate. Look, this portion is 2. Okay, this height is 2 for B. if B reaches the plane, same 2 meter height will be traveled by A also. Suppose here this is 2 meters, okay, 2 meters. So when B reaches the plane, A reaches at this height. So what will be the height from here until the plane? It will be actually already 1 meter. It is above 1 meter. Then 2 meter is traveled. So total 3 meters. Total 3 meters have been traveled by A. So once again I am clarifying that when B reaches the plane, B is traveling 2 meters, okay, and A is going upward also 2 meters. This is 2 meters, okay. So 2 meter, when A goes up 2 meters, A was already 1 meter above the plane or reference line. So for A it will be total 3 meters. But they told us to find the distance which should be at least 2.5 meter, at least 2.5 meter, okay. So let's see once again, we are going to see this is actually 3.25 meter. Now if we observe that already whenever whenever B reaches at the time instant, reaches the plane, then A will cover total 3 meters. I think you have got it. Then up from 3.25, they told the distance should be 3.25. From 3.25, if 3 meter is subtracted, then zero point 0.2 meter should be traveled by A. So this is one of the concept. As I have told, the question seems to be very simple, but it's a twisted question, okay. So the twist, we are going to find out the twist little by little. First twist is, it requires actually 0.25 meter to be traveled. Then second twist is, look, A is actually moving upward, okay. So what will happen at one stage? Look, it is moving upward. It will go downward again, come back downward, because when B is at the B touches the plane, horizontal plane, the question says it will be, look, it is written over here, A doesn't reach the pulley, and after B reaches the plane, it remains in contact with the plane. There is no movement after touching this reference line. So whenever B touches the ground, then when B touches the ground, there is no more force is acting on them. Then what will happen, as there is no external force, if this is A will go upward, and at one stage it will come down again. So this is the second twist, that for A having no external force, it will come down. Whenever some particle comes down from the maximum height, so it was actually zero. Maximum height is zero, though this is not necessary for us. Not maximum height, maximum velocity was zero at this point, which is not necessary for us. Well, so what is the concept we have learned? First, we have learned that when A reaches the reference line, I mean horizontal line, then B has already traveled 3 meters. Then there remains only 0.25 meters to reach. And suppose here there is 0.25, okay, 0.25. So when it comes back again over here, then there is also a distance traveled by this. Let us solve this and find out this twist again. Our question is, it is, I have written over here, velocity of a when B reaches the plane. We should know the velocity of B, velocity of both of them when A reaches the plane. So the concept, a super concept, same concept, V square is equal to U square plus 2AS. When A reaches, this is the plane, okay, A is at this stage. When A reaches at this point, the question told that there is no more force acting, that is, it is in contact with the plane. That means V is, final velocity is 0. Here final velocity is going to be 0 for A, okay, it is 0. Now you may ask one question, that velocity of A when B reaches the plane, what is the connectivity between B and A? Actually, as both of them are undergoing the same tension, same force, same acceleration, so velocity of both of them will be also same at until it b reaches the reference line. Well, so the concept is v square plus u square. V square is going to find for in term of b we are finding actually, because the acceleration or velocity of b is applicable for a also at the same instant, at the same until the same time. Okay, v is equal to square initial velocity is 0 because the particles were released from rest. So v square is equal to 0, 2 into and 2.5. I have I think that we cannot forget that acceleration is 2.5. We have extracted from the previous question, and displacement is 2 for b. For b, because b is, suppose b is coming down here and this distance was 2 meters. Okay, so velocity is actually square root of 0. So this is the velocity for b. This is final velocity over here. Okay, the same velocity is active until it for a also, until a reaches up to this. If I show you the figure properly, then you can assume that, look, a is a is I mean b is coming down here. Okay, b has come down over here, whereas a is going up to this stage. Okay, so b has come down 2 meters, then a has also come up 2 meters. The height is exactly same. So what has happened to a? Actually, first a was 1 meter above, then it has traveled 2 meters. So total 3 meters. Total 3 meters have been already traveled. How much is remaining there? How much is to be traveled? 0.25. Already I have shown from the previous question, previous part of the this solution. So 0.25 meter is to be traveled. Now remaining distance I have written here. Remaining distance is actually 3.25. From 3.25 already it was 1 meter above and 2 meters have been traveled. So ultimately we will have to find out this distance. Distance is 0.25. Now for 0.25 we can apply, as we know acceleration. We know acceleration as well as we know initial velocity, and displacement is also known to as displacement is 0.25. Now you may ask what is the initial velocity. Look, the final velocity at this point when it reaches 2 meter above. So this is the final velocity for this part. For this part this is final velocity, whereas for the part above this, for this part the initial velocity is also same. So final velocity at this point, final velocity for the lower part must be initial velocity for the upper part, because the particle is on the move. So we have got our displacement is 0.25, because we are going to calculate the time when it reaches at least 0.25 meter distance. Then initial velocity was 2. For final velocity of b is the initial velocity for a, or in another way as I have told, final velocity of this, yes, for this height, final velocity for this maybe it must be the initial velocity for this, the point is same. Okay, so it's square root over 10t plus. Now look at this, what is happening. Let me show you the figure. Why have I written here negative 10 as acceleration? Because whenever, look, b has touched the ground, when b touched the ground there is no more external force which is acting on a. Let me show you the given figure again. The given figure is this. When b touches the ground, look, b touches the ground and it is in contact, look, in contact with the plane. Okay, when it reaches here, then there is no more external force acting on any one of these. Then at this stage, suppose at this stage when a reaches, then on a and b no other force is acting. So what will happen? Just it will go up as continuous movement, then again it will come back. For a will go up at one stage, then it will come back. That's why the final velocity, I mean Final velocity is 0 because there is no more velocity at the maximum point. But the question we are going to know that how can acceleration be negative, because as there is no other force acting on the external force, neither the tension, only weight is turning it, pulling down. Weight is pulling it down. This is the particle A, and it is being pulled down by what? By the weight. Only weight is the force which is acting downward. And you know, acceleration, okay, the acceleration is, we are searching for acceleration. What is this acceleration? Acceleration is acting downward, the particle was moving upward, so that's why this acceleration is negative, and this is nothing but the acceleration due to gravity. That's why this is negative 10. Actually acceleration is, there is no other force acting on this, only the acceleration, gravity, acceleration due to gravity is acting, and as this is particle is moving upward and acceleration is acting downward, that's why this is negative 10. We have multiplied by negative 10. So you have understood that why have I used this negative 10, because acceleration due to gravity is pulling it downward. Well, then it is a negative 5t squared. If 2 dissolves this 10, it is going to be 5. So 5t, negative 5t square, then plus square root over 10. Then if 0.25 is shifted to the other side, it is going to be negative 0.25. Then simplifying the symbols, we get 5t square minus negative root over 10 plus 0.25. Well, then let it be written. I have already written it beside this solution. So our equation is 5t square minus square root over 10.25, and we can solve this quadratic equation. T is equal to negative b, and negative negative, this is going to be now positive. B plus minus b square minus 4ac, you know it very well. Then we got square root over 10 plus minus square root over 5. 4 5s are 20. 20 into 0.25, it is actually 5. Then t is, we are getting two values. This is the most twisted part of this solution. We have got two instants, two time. Now how to calculate and pick up the right time? So let's go back to the question again. They have told us to find, let me show you here. What did they write? They have written, they made it very twisted. They have written here the time, find the time for which A is at least 3.25 meter above plane. So we have got two time instants. So which one is to be obtained? Actually, the question should be written the duration. Instead of time, they could have written find the duration for which A is, suppose this height. Okay, this is, here is 3.25. Suppose 0.25 or 3.25, whatever we tell. And at this time, this is height, this is the 3.25 reference line. So they have told us to find this because the particle was going up and coming downward. So at the time, what is the duration when the particle is above 2.5 and coming back to 3.25 as height? So it's actually not time, this is duration or time period. But we may get confused very easily that the time means whenever it reaches this height. Whenever it reaches the height, there may be one time, the minimum time can be taken, but they have between these two values of t, the lower one is actually, this is the points when the particle reached here. But they have told find the time for which A is at least 3.25 meter above the plane. So at least 3.25 meter above the plane is this. Actually plane is over here, this is the plane, and here is 3 meter, this is 3 meter, uh, then 3.25 meters will be here. Okay, that means 0.25 meter. So actually the question, this is the another twist that they have told the time when the particle was above this line, so this is the most complicated twist of this question. So let's solve the 2 points, two values we have obtained. The values are, we have got one of the values. Look, one of the value is this when p reaches, I mean p reaches this is, okay, So A is this point, this is 0.25, okay, at this height, okay. Suppose, or you may tell in terms of this reference line, this may be 3.25, and here this is the base of the plane, okay. So when it was at 3.25 height, then the particle, we have already decided particle is coming down. So they have actually asked us to find the time, means the time when the particle was above this. Once it went up and it goes down of this height, so it is not actually time, this is the duration. That's why I have written duration or period of time. Once again I'm repeating that this is, look, this is the particle has gone up here, then it has came down. So this is 0.25 or 3.25. At this they have told us to find this portion, okay. When the particle is floating or above this height, what was the time period, not actually time, it will be time period or duration. So as the second, first the time when t reaches here, look, T took this 0.0926 second for reaching here. Okay, at 0.0926 second, the P is over here, and again P came back to the same height after 0.5398 seconds. So first it was at this height, and again it reaches the same height at the time of 0.5398. So they have told us to find the duration. So how can we find the duration? From this greater second, greater time span, if we subtract this one, lower one, we will get the duration when the particle was above this height. So I think you have understood the twist of this question, that we have just subtracted. So it should not be time, actually it should be duration, or the time when the particle was above 3.225 meters. I have written for our better understanding, I have written duration or time span or period of time. We can write here time span also, time span. It should not be actually time. Time means at the time when it reaches. So when it reaches, we can tell from here, look at this, it reached at this height 0.0926. So this should be the answer. But the twist is they actually didn't ask us to find the instant or time when it reaches. They told the height should be above 3.25, okay. That means this portion they told, not as an instant of second, in an instant of time. They asked for the time period, means the duration. So first it has reached at this time, and then it came back at this time. So the height above this is this, and the time duration is, I have written as, so from the last time, or the second time instant, we will subtract the first time instant. So after subtracting, and as I have told, it's better written if we write here duration or period of time or time span, particle B remains above 3.25 meters. So from the second or larger quantity of time, we have subtracted the smaller quantity, and actually 0.447 seconds the particle stayed above this height. Here is point, suppose it's 0.325, point 3, sorry, 0.25, not 0.325, 0.25. This is the reference line, and the particle stayed for 447 seconds above this. So this is actually the twist. I tried my level best to clarify the twist. If you have understood, then it will be my pleasure, and I'm really thankful to Almighty Allah for explaining this, for making it a little bit easier to understand. If it is understandable and solvable by you, then please pray for me to the Almighty Creator, so that Almighty Creator blesses me with all His bounties. Fi amanillah. This is the whole solution to question number B. You can have a look at these. Then I can show you the solution number A. For the last time, it was the solution number A. let me erase all unnecessary part. You can copy from here. So in brief, I have tried to explain both the solutions, and I believe that you have been benefited by this explanation.